This is section 2.5, Transformations of Functions, part 3.
So y equals f of x is our original function. Then in g of x, we have f of x minus 4 minus 2. This minus 2 is outside of the function. It's not housed in with x, so it's going to affect my y's, up or down movements, and y's are true to their sign, so down 2 units. This minus 4 is housed in with the x. It's inside the function, so it's going to affect my x's left or right, but it's not true to the sign, so minus 4, I would want to go left, so I'm going to go right instead. Okay, y's true to their sign, x's not so much. Okay, so every point on here on this graph will go right 4 units, down 2 units. So starting from that negative 4, 0, I'm going to go right 4 units, takes me to the origin, and then down 2. Okay, and just do that for all the other points. So I'm just traveling right up diagonally to that next point. I'm going to go over to the right for 4, and then down 2. So that movement went like this. Okay, next one, over 4, down 2, over 4, down 2, and then over 4, down 2. And that would be the graph you'd be looking for. So do you see how it took the figure and it moved it to the right 4 units and down 2 units? Okay, so same thing here. We have f of x shown on the original, and we're doing g of x equals 2 of f of x plus 3 minus 2. So let's talk about what's happening here. This right here tells me that it's going to move down 2. This right here, housed inside of the function, is telling me that it's going to move left 3. This right here tells me that it's going to stretch vertically. So it's going to get taller. That means it's going to get thinner because it's going to stretch vertically and get taller and thinner. All right, let's see. So I would look at the origin, and that's where I'm going to start. So focusing on my 0, 0 point, I'm going to see, okay, which one moves to the left 3 and down 2? This one moves to the right, A. This one moves to the left, so I'll keep that in the mix. This one moves to the left, but it moves up, so it can't be C. And then D moves to the right, so it can't be that one. Now, even though I narrowed it down to B, I still would click on the magnifying glass to make this graph bigger and just confirm that I didn't overlook something. So this would be my answer. Okay, so the answer is given on this one, but that's okay. We're still going to talk about it and see how we got there. So my original function is given on the graph. And let's talk about what we're looking for. So this plus 1 is inside of the function, meaning that it's affecting my x's. I'm going to travel left 1 unit. this right here, the coefficient out in front of the function is between 0 and 1. And so we're going to shrink vertically. So all my y's are going to become half of what they were before. Therefore, my graph will get wider. Okay? Again, you can take one of the ordered pairs off the graph and then sort of see from there, okay, did it move up, down, which way? So I know that I'm moving left 1 unit. So I'm going to get this 0, 2 and see which one moves left. Okay, this one moves left. This one moved left. C moved right. And D moved right. So I eliminated C and D. Okay. Now I'm stuck with A and B. What I'm looking for is that it shrinks vertically. And so here we see 0, 2. Well, now this is at 0, not 0, -1, 4. So my Y actually went up on this one. So it would not be that one. But here, my Y for this coordinate, it moved after it moved to the left 1 unit, it dropped down to 1, which would be half of 2. So that's why B would be my answer. Again, please make sure that you use that magnifying tool because it's much easier to see those graphs and just the exact points. And so you could eliminate some mistakes by using that. So with horizontal and shrinking and stretching, you're going to have the opposite of what you think would happen. So here, if there's a coefficient that's greater than 1 in front of the x, so now we're talking about inside the function. Here we see that it's happening inside the function. X would actually become less, and this is why. If x before was equivalent to 8, now 2x would be equivalent to 8. And that would take 8 down to 4 now. So if there is a coefficient that's greater than 1 in front of the x inside of the function, the opposite ends up happening. On the flip side of that, if I had 1 half x equals 8, look what happens. Now my x becomes greater, right? So just keeping in mind that we're going to see the opposite. We're doing the opposite. So up here, the only thing that they have is f of 2 of x. So my original function is just y equals f of x, and now they want us to find g of x, which is just f of 2x. That's the only change. And usually what I do is I find the vertically or the horizontal shrinking and stretching out of all of them the most challenging to wrap my mind around. And so if there's other things going on, I will get that knocked out the way first and identify my graph that way. And then if I have to use this one, I'll use this one. But generally, that's just how I do it. And because this one, just out of all of them, it's like, wait, how does it go again? Okay, so if it's 2x, then it's actually going to be, shrunk. And when it's 1/2 x, then we're going to stretch it. Okay, so what I'm looking for now is -4, 0. So all these points right here, -4, 0, -1, -2. So notice I'm just changing my x's to half of what it was. 1, 2, 0, 0 stays 0, 0, and 4, 0. So just changed all of my x's to say what I'm looking for. Well, looking at A, and again, make sure that you're using that magnifying tool. We can't do it on this slide, but I definitely would. So looking at this, I'm like, okay, I can see that those points came in on A, horizontal. So I'll keep A around. B, same thing. I can tell that horizontally it shrunk. Okay. C, it's stretched out horizontally, so I'll get rid of that one. And same thing with D, it has stretched out horizontally, so I'll get rid of that one. Okay, so now looking at this, I'm looking for -4, 0, -1, -2. Well, this is definitely lower than -2 for my y. So -1, yes, it went out -1 to the left on the x-axis, but it drops way too low. And then I still check my other points. So this point up here should be 1, 2. That looks more like 1, 4. So A is not looking like it's going to fit the bill. And then I look at B, and I still want to confirm that this matches what I'm looking for, because if I overlook something in one of the other ones, then I'll just automatically get it wrong. So -4, 0. Okay. This one should be -1, -2. Okay. This one looks like 1, +2, and then this one looks like 4, 0. So B it is. Okay, it tells us to sketch the graph of the function. So I can just graph this, right? I'm going to go ahead and graph it. So I want you to practice graphing it too. Go ahead and punch it into your calculator and let's see what we get. Okay, have it entered into the calculator. Then we execute, and I'm looking for this in my graphs. So notice, let's talk about this really quick, that I moved down 1 and right 2. That says right. Okay, right 2 units. So the fact that these ones moved up, I can get rid of them. And then this one moved left, so I can get rid of it too. So technically you don't even have to graph it, but I think it's just a nice way to confirm. And it might look a little bit different, so it looks a little bit wider on our calculator. It depends on the settings of your window, so be careful of that. Okay, so same thing here. Let's go ahead and do it without using a calculator. So I know that this is going to move my function right 2 units. And then this negative out in front of the function will flip it over the x-axis. Okay, so I can get rid of this one because it's not flipped. I'm going right 2 units, so B's looking good. C moved up 2 units before it flipped or after it flipped. And then D moved left 2 units, so I can get rid of that one. So B moved, again, I would still magnify it if I could, moved right 2 units, and it flipped over the x-axis. Okay, so this one's graphed for us. I would say be very careful on this one because I feel like the picture from our calculator can be very misleading. All right, so let's talk about what we're looking for. I'm going to write this a little bit bigger up here. H of x equals 2 times the absolute value of x plus 4. So the plus 4 is inside of the function, so I'll be moving left 4 units. And then the multiplication of 2 in front of the function, right? So it's not housed in with the function, will affect my y's, and that's going to stretch it vertically. So it should become more narrow. Okay. First thing I always, like I said, leave the stretching and the shrinking for last to look at that. I try to eliminate answer choices based off the movement left and right or up and down. I should have had that function move left 4 units. So this first answer choice could possibly be it. This one, the second one, it did not move left 4, so we'll knock it out. The next one moved right 4, so we'll knock that one out. And then this last one also moved left 4 units, right? So based off of the picture of my graph from my calculator, that more closely resembles that last answer. But remember, we should be looking for something that is stretched vertically, that's more narrow. And so be careful for the windows and just what you're looking for based on what the calculator showed you. So the answer is actually this first one. But again, just be careful that you just don't punch it in your calculator and say, oh, okay, it must be answer D, right? That's why it's so important for you to understand what each part of the function does to that original basic function. Okay, they want us to write the domain and range of the function. So the very first thing you would do is graph it. Okay, it's graphed for us. That does match that it moved up 5 units. It moved left 5 units, and then it flipped horizontally. Oh, I'm sorry, vertically. Let me put over the x-axis. Okay, the domain is all the possible x's, right? So remember, this keeps going on and on and on, downward but moving towards the right, and this came from the left, and so domain would be negative infinity to positive infinity. Okay, then the range, we're saying, okay, what are all our possible y's? Well, think about this. It's coming from downward, right? And it continues downward. So coming all the way from negative infinity, but there is a point that it stops. So remember, our original vertex was here at 0, 0. It moved up 5 units. So after it moved up 5 units, then it moved to the left 5 units. But the highest point that it goes to on the y-axis would be 5. And it includes 5, so we use brackets.